We are in the second chapter of college algebra, and 2.1 starts on page 176, but everything on 176, 77, and 78 is pretty much old stuff, so I'm going to skip that. You can peruse that if you want just to see what I skipped, but you'll see that it's stuff that is basic Algebra 1 that you've already done. So we're just going to start where this section is pretty big on story problems. So we're going to start on page 171 or 79 with example 3 and go from there. So we'll just do some practice ones here. So Americans spent about $511 billion. Okay, I'm just going to leave it as 511 in 2006 to go out to eat. And this was an increase over the amount spent in 2005. So what we've got here is looking at an increase rather than a decrease or something like that. So what they're wanting to know is how much was spent dining out in 2005. And all they tell you is this number here was a 5.1% increase. So what we need to do then is find this number right there. Okay, so let's see what we can do here in order to find the answer. Now first of all, what we want to do is we want to look at what happened in 2005. So what was the percent of people that ate out in 2005? Well, it was 100%, right? All the people that went out to eat in 2005 went out to eat in 2005. All of them. So 100% of them did. There was a 5.1% increase. So we increased it by that. So what we're going to do is we're going to take 100% and increase it by 5.1%. And we get 1.051% increase. Okay, so that is, well, I guess that's not the let's take the percent sign off. We have the decimal there, so we don't need a percent sign there since we already changed it to decimal. So that is what we're going to multiply by the amount of money we spent in 2005 in order to get the amount we spent in 2006. So how much did we spend in 2005? Well, that's what we don't know. So we're going to call that amount spent in 2005. We're going to take that times 1.051 or 105.1% to get how much we spent in 2006, which in this case was $511 billion. So instead of calling this how much was spent 2005, we're going to say 1.051x equals 511. Divide both sides by 1.051 and you'll get the amount that was spent in 2005, and it needs to be smaller because in 2006 that amount increased. So let's look at example 4 on page 180. We've got some veterinary expenses here. We've got a dog owner and a cat owner spent an average of $376 a year on their animals. Okay. A dog owner, so that is together a dog owner and a cat owner spend an average of $306 annually. A dog owner spends $150 more than the cat owner. Find the average annual veterinary related expenses of a dog owner and of a cat owner. Okay, so what we're looking at is both a dog owner and a cat owner. We do know that they both, when they add up the cost, they pay $376. So the amount we spend on a cat, the amount we spend on a dog, when we add those up, we should get $376. So let's look at what we've got here. We know something about a dog owner. They spend $150 more than a cat, but we know absolutely nothing about the cat owner. There's no number to relate to it or anything, so we're going to use X for our cat owner because that's the one we know the least amount. And then we're going to compare a dog owner with that. A dog owner spends $150 more than a cat owner. So 150 plus X. So that's what a dog owner spends. So if we take the cat owner and the dog owner and add those up, so the amount we spend on a dog, the amount we spend on a cat, we should get $376, right? Because that's the amount we spend on both a dog and a cat. So you go ahead and do the math there, and you get X equals $113. So a cat owner spends $113, which means a dog owner would be $113 plus $150, so that'd be $263. So that's how much we spend on a dog and how much we spend on a cat. Okay, we're going to finish 2.1a with some motion problems. And this is where we use D equals RT. And what I would suggest, whenever you do D equals RT, I would make a handy dandy little graph here so you can put some information in there. And we will break this up and do our distance, rate, and time. And we'll see what we've got here. So, America West Airlines fleet includes a Boeing 737, each with a cruising speed of 500, and a Bombardier de Havilland Dash 8-200s each with a cruising speed of 302. Alright, so we're talking about a speed. One goes 500, one goes 302. So that is what our rate is. So let's put 737 and let's put a dash as our two planes. And let's go ahead and separate those here. Now our 737, it said goes 500 and our dash goes 302. So we already know the speed of those two planes. Suppose that the Dash 200 takes off and travels at its cruising speed. 1 hour later, the 200 takes off, 737 takes off and follows the same route traveling at its cruising speed. How long will it take the 737 to overtake the Dash 8? Alright, one of the things that you need to know right now is that when the 737 catches up to the Dash 8, they will have traveled the same distance because they started here. So let's say that the Dash 8 takes off and he's flying along here and he gets here, and then the 737 takes off an hour later and travels and travels and travels and travels. At some point it will catch up to the Dash 8. When it catches up, they will have gone the same distance. It took this plane here goes faster, so it doesn't take as long to catch up. But once he catches up, they have gone the same distance. So we start the timer right here, and we measure how long or how far both these planes went when he catches up. At that point, they're both in the same place. They went the same distance. So we're going to call this distance here and this distance here the same. D and D for distance. Okay, let's look and see what we know about time. The 737 takes off 1 hour before, or the Dash 200 takes off 1 hour before the 737. Okay, so if we call the 737, if we call that time, and it doesn't matter which one you call time, you just have to compare the other time to that one. So the 737, we're going to call that T. The Dash 8, we're going to call T plus 1. Now the reason we're calling that t plus 1 is because it took off an hour before, so it's been in the air not only as long as the 737, but it's also been in the air an hour longer. So let's say that the dash started at 8 o'clock and the 737 started at 9, an hour later, and they caught up at noon. Well, the 737 started at 9, so it's been in the air 3 hours. This one started at 8, so it's been in there 3 hours plus an additional hour, so 4 hours. So see how that works? So the dash has been in the air longer, so we're going to add an hour to it so that we know how much time compared to the 737 it actually stayed in the air. Okay, so I move the graph down a little bit, and let's see what we have. We're using the formula d equals RT. So let's look at the RT of the 737. It's 500 T. Let's look at the RT of the dash. It's 302 times T plus 1. So the distance of that is 500 T, and the distance of that is that. What did we say about the distances here? We said that they're equal. So if these distances are equal, then the RT and the RTs are equal. 500T is equal to that. So you do your simple algebra, and you're finding out that your T then is very close to 1.53 hours. Okay, so 1.53 hours after an hour and a half, after 1.53 hours, after around an hour and a half after the 737 has taken off, it will overtake the Dash 200. So they just want to know how long it will take the 737 to overtake the Dash 8. So we start it when it takes off and look and see how long it takes before it catches up. And that's about an hour and a half. Okay, so that is 2.1a.